All right, we're in Holt Physics, Chapter 3, Problem E4. And in this problem, we have a salmon that's jumping upstream, and it needs to leave at an angle of 32 degrees, and it has to cover a 0.55 meter cliff, half a meter, a little more than half a meter, and it has to travel 2 meters. So we first draw our picture, and then we set up our chart with our x and y coordinates. Looking at this, we choose our coordinate system, positive x in the horizontal direction, positive y, upwards, starting from where the salmon leaves. And we start with our initial position in the x direction is 0, and the initial position in the y direction is 0. Then we get our final positions. Now, what do we do for initial velocity? We only know the angle. So first we need to find the x and y components. So drawing a larger triangle to make sure this is seen a little better, VIY will be VI times sine of our angle theta, knowing that V initial is unknown. VIX is VI cosine theta. VI is unknown, but we're going to put that in for our VI term for x and y direction. And then we know the acceleration term. In the x direction it's 0, and in the y direction it's 9.8 meters per second downward. Now what do? We don't know time and we don't know V initial, but fortunately we have two different directions to work in. So we can solve with two equations and two unknowns. In the x direction, our equation of motion is x equals x initial plus vi in the x direction times time. X initial is 0 and vix is vi cosine theta, so we're going to write this equation out. And then we're going to go in the y direction. And in the y direction, we get y equals y initial plus viyt plus 1/2 at squared. Looking at this, we can solve that y naught is 0, viy is vi sine theta, and we get a long equation. Now we have two equations, and we do not know V initial and time. So with two equations and two unknowns, we solve one of the equations for an unknown, plug into the other one. This one, equation 1, is our easier equation to solve for an unknown. I'm going to solve for VI and plug into equation 2. The reason I chose VI is it's only in one spot. I could have solved for T, but with a T squared term, things get a little trickier in that case. But we would get the same answer. But what we're going to get is VI equals x over T cosine theta. That's solving equation 1. We're going to put it in equation 2. Y equals x over T cosine theta times sine theta t plus 1/2 at squared. Now you may choose to start putting numbers in here. I will suggest that you're better off solving the equation, noticing that you can cancel out t, and then we can subtract that first term from both sides and get y minus x sine theta over cosine theta equals 1/2 at squared. Now I'm going to multiply by 2 and divide by a on both sides and then take the square root. And this is the term I get. Notice t is in terms of all digits or all variables that we know. And we solve that time is a little more than 1/3 of a second. So the salmon is in the air for 0.3779 seconds. Now we go back to equation 1. We've already solved for V initial in terms of position and time and angle. So we can just plug in our time in equation 1. And doing that, we get 6.24 meters per second, which is the answer to the problem. I believe we can round to 6.2 meters per second to keep our sig digs in order, but this is the methodology we should use for these type of problems, and thank you and good luck.